Hello, I'm Fabijan, and I'll be presenting the Advanced Materials Department of the Stefan Institute. So we just start off right in the beginning. Where are we? So the Joseph Stefan Institute is located here in Slovenia. We are the foremost scientific institution in Slovenia. We have about 1,200 employees, most of whom are PhD level researchers, though there is a lot of us technical staff around as well. And what do? We do everything, most everything science related. We do particle physics, robotics, nanotechnology, AI, biomaterials, environmental studies, nuclear engineering, high-tech coatings, theoretical physics, telecommunications. Basically, whatever kind of science you can imagine that falls under the natural sciences, we're into it. Now, that is a lot to deal with. Thankfully, the institute is separated into a large amount of almost independent departments. We do share some things, like some facilities, some general management, but we are mostly independent in our work. So who we actually are, I am presenting here the work of the Advanced Materials Department. This is a coalition of 20 researchers, 6 support staff, and about 10 students on any given day. And what do we do? Well, traditionally, we were mostly interested in creating ceramic materials for use in telecommunications. But as we all know, mobile phones work now and they work really well. So that field has been somewhat exhausted. So we spread our wings and expanded into things like glass foam insulation, antibacterial fibers, post-laser deposition of thin films, 3D printed ceramics, green hydrogen production, nanoparticles, and as I just learned today, materials for detecting explosives. So a very, very wide range of work. And it is somewhat difficult to keep a group of very diverse people who work on very diverse topics to have some sense of cohesion and some sense of, well, some way of keeping the data sane. I'm not going to say organized. We are just going for the level of sane at this point. Oh, and what's my job here? I'm the technical expert in complex dielectric permittivity measurements, aka I'm your local lab monkey, taking care of, well, taking care of our researchers so they can do their job as efficiently as possible. So our story with Grist begins somewhere March or April last year with a slight failure. We can't have the successes. There are some slight failures, and it begins with this, a missing box of A4 paper. Why are we missing it? Because we had to print out a whole bunch of questionnaires, which we are supposed to then fill out by hand, and some postdoc has to copy all of the data into Excel. Honestly, I almost forgot what the questionnaires were about, but yeah, ran out of paper, had to find more. And I was just thinking to myself, this sounds like a 1980s problem, like having people fill out forms and somebody manually putting them into Excel data, Excel spreadsheets. That sounds like a last century sort of issue. Could we perhaps bring it to the 21st century, if not to 2024? So I was looking for something that would be sort of like MS Access-like, because I remember that from way back, but better. So possibly online, interactive. And they found some things like Airtables and stuff like that. But the best thing we found was Grist at that point. It had forms, which were what we needed. It had tables. It looked awesome. But we only had like 2 days to get the whole thing up and running. Did not really work out. Also, at some point in the middle of this process, we figured out, it would be really nice if you could put maybe files or images into forms. At that point, that wasn't available. So we gave up on the idea. So now that I think about it back, you can't really put images on paper either, at least not easily. So at least I can't. Some people are more artistically inclined. So yeah, we gave up on Grist at that point. But at about the same time, we got a new lab. It's wonderful. And with the new lab comes a whole bunch of new problems. Specifically, the problems that we had were like, oh, we have a bunch of chemicals. By a bunch, I mean about 1,500 different chemicals at that point. And this is how our notes used to look like. They still do look like that for some of us. So, no. While this seemed to have worked for the last 20 plus years, it is a bit unseemly, shall we say. So we were looking at how does one manage a lab? Of course, what do you do when you're looking for something? You put it into Google at that point. Now you'll probably put it into ChatGPT. And of course, you figure out there is something called lab management software. And we tried, I think, 3 or 4 different versions of it. And what it turns out is that lab management software is, in general, awful. It is usually either useless or useful in a very specific setting. Let's say there is great lab management software if you, for instance, have a wine testing laboratory or a gene testing laboratory. But if you have something that deals with basically 10 different topics, it's just not dynamic enough to actually do the work. So we thought about some of the requirements. And the requirements were, we want the software to be locally hosted because, well, we do have some private information and we don't want to share it too openly. We wanted to enable us to manage our chemicals, manage our publications, manage our monthly reports, and be, if possible, not too expensive. And then we had another set of requirements, which would be that the software should be open source. It should be dynamic enough that we can make changes on the fly when needed. It should be expandable. It should ideally have an API, and it should be, Python friendly, if possible. Got a bit lost here. All right, moving on. Uh, yes, Python would be a nice thing. So one list of requirements is from the administration. The other was from me as the responsible developer at this point. You can guess which one is which. So the first thing that we started off was a table of chemicals. And this is our example of such a table. It's a pretty simple thing, really. There's a search bar we added up recently, a nice thing. There's a long list of chemicals. There's some details about each chemical. And there is this little bit here, the print option, which is basically just an HTML widget, which shows this HTML. And this is our first use of the API. We built a very, very small piece of code on the backside in Python and Flask, which basically gets the line from the chemical table and prints out a QR code. We end up with something like this, a chemical which then has our label on it, and there is also an accompanying super small Flask widget Flask application that's optimized for mobile viewing, so you can scan your chemical and you get the basic information about it. Like you can get the safety data sheet, the name, the size of the bottle, and where it's located, and also the status. Let's say this thing is have full. This was one nice use of the API, which would be quite hard to achieve with most any other software. Now, the other trick here in this particular view is a bit less obvious. It's this bit here. It's the safety datasheet PDF and the dangers. We did unfortunately have to employ somebody to actually, find the 1,000+ safety datasheets. But a nice thing that you can do in Grist is, have a webhook, and when somebody uploads, say, a PDF, you can take that PDF, do some regex searching across it, and actually find what are the actual dangers of our chemical. This is a slightly silly trick, but it does save probably a couple of 100 man-hours in the end. It's amazing what you can do with regex and a good API. The good API will be a recurring theme in this presentation. So yes, publications. This one, hopefully, I can actually show you in action. it's a quite a nice trick. So this is our publications card, as we call it. So when you publish a document as a research scientist, you get a so-called DOI link, which is the official link of your article, no matter which journal you published it in. And there is a nice little trick. If you put your DOI link into Grist, you can get all the data about the article. Let's say the title, all the authors, when and where it was published. So how does one do this? Well, by being a bit sneaky and actually importing the requests library into Grist. We had to do a custom build of Grist to do this. The inbuilt request function did not work quite well enough because we're doing the proxy system to get out of our slightly locked down self-hosted system. But yeah, you can just go out, find an API which is gonna get you all the data for your publication just from the DOI, and then you can use smaller little Python functions in your Grist table to actually get the relevant data out of the system. So this would mean that things like where do we have the publications? Yes, publications. Yes, things like a list of all the authors, the name of the thing, the ID of our library system, stuff like that. I think that being able to actually import almost any Python library into Grist is an amazing feature which you don't see in almost any other software at this level. So another thing we wanted was monthly reports. This is quite an easy thing, really, but it does have one little trick as well. Oh, I'm so sorry about that. I think we're going to be skipping monthly reports, but basically, what you can do with using the API is just, occasionally check your quiz database and send people email messages. Let's say, for instance, you forgot to input your monthly report this week, this month. Again, it's a very simple way of incorporating email notifications. You can use the API for that. It's a bit iffy. You don't have to have extra servers running on your server, but it is doable. And you can add extra rules in it if you want. So another area of managing a lab is dealing with the data you create. So this is a somewhat complicated project, but this is my favorite part of the work we've done, because basically we have a whole bunch of devices such as this wonderful 20-plus-year-old X-ray diffractometer. And what you want to do is get the data from this device and somehow connect it to the research that people are doing. So how do we solve this thing? Basically, when you do a measurement under this device, you can add a comment to it. In the comment, we instruct people to add the Grist code. So maybe we should take a step back. We first define the idea of a sample, which has its own Grist code, which is just the ID of the it's just the ID of the sample in the samples table. And if you put this ID code into the device, when you do as a comment when you do the measurement, it will automatically link the sample with the measurement. And how does it do this? Basically, it checks the device every now and again for new measurements. It downloads the measurement. It extracts the data out of the frankly awful proprietary data format, puts data into Grist, and does a few things with it, like finds the peaks of the data, plots a nice graph, and ideally also links the data to your sample. Now, as you can see, the samples column is somewhat empty because most people do not actually put the sample data into the system yet. We are working on that. But still, even without that, we are actually picking up all the data. And we did this for, about 10 or so different devices, ranging from things built in the very late 70s to things built earlier this year. So, you can abuse the API a whole lot to get data into Grist from things which weren't meant to put data anywhere, except maybe a ancient printer. So that's a interesting use, I would think. Oh, and this is possibly my favorite part of Gristifying a laboratory. If you have a user who is slightly more software oriented, because while our users are intelligent and well educated, they are not particularly good at software development. They're chemists, they're geologists, they're physicists, but they're not software developers. However, if you find a user who is somewhat software talented, you can do interesting things such as, use the built-in Python environment. So the built-in, what is it? Jupyter Python environment in Grist to actually define, let's say, a composition for something called a slurry, which is used in 3D printing. You can define it. You can have a few methods, use some mediumly fancy linear algebra to actually calculate what the actual quantities of materials you're supposed to use are, and then put out a nice recipe here in the bottom right. Say you need this much mass and this much volume of this material, and if you follow the recipe, you're going to get a wonderful slurry for your 3D printer. This has turned out to be an extremely useful approach to basically programmatically define the processes we are doing and get out things that any student could use. You give them the table, you give them a scale, and they'll make this thing for you. It does require a somewhat more software-oriented user to do this, but it is possible. Now, the only problem here is, of course, that while our measurement data is very much the same between all users, and it's in a way what connects the department together, the actual process of making the samples is almost user specific. So it's something we have to develop on a user per user basis. Some people are more receptive to that, some people less. But with Grist, you have this wonderful dynamic capability that, one afternoon when the user has time, you can sit down with them and create something that works for them. It might not be pretty. It's not pretty because I'm not particularly aesthetically inclined, but it does work. And if the user is particularly aesthetically inclined, they can make major upgrades to what you create for them. So where are we going? Yes, this is our plan for the foreseeable future. We have added a few things already, such as scheduling equipment maintenance, a simple to table work job in Grist, automatic imputation of measurements. We are not yet at 10 plus, but we are getting there. Expanding the processing part. So we saw here how you can make let's say, a process for creating 3D printable materials, but we have also done work on other processes, such as how to make a process for creating nanolayer thin films using lasers. That's the POD method. Or how to make a piece of ceramic in a very classical method by, firing it at 1,500 degrees. We have also found that Grist is a great source of data for a web page we are rebuilding. Now there are some things that we are planned for the, let's say, foreseeable future, whatever that might be, such as when we create a sample, actually being able to track the lifetime of the sample, like which processes were used to create it, which measurements were done on it. This is now already being tracked in the form of a table, but we are looking into using some sort of slightly more advanced widget to do this, I think with a flowchart-like element to it. Ideas about that are welcome. And we are also planning on expanding the chemical storage system, which was the first part of our Grist system that we developed to other departments. So Grist is spreading, and I think we can all agree that's a good thing. Now, there are a few issues we are dealing with. One is that, and this is completely my fault, right now we are storing all of our data as a single document. Why? We'll get to that in a bit, but I just looked at it, at 177 tables right now, which is about the upper limit of what Grist can take, especially because some of our tables contain a large number of files. The files are going to be at a very near future split from the main data table, so that's going to hopefully help us out somewhat, but still, it's a very large document. Now, we are planning on splitting it somehow. But the issue we are having with that is that there is some data that we do plan on having in all the documents, such as the user table of our employees, the table of samples, the table of equipment. So exactly how the splitting should be done, we have not yet figured that part out yet. So again, open for input, open for questions. And also, is there anything we are looking for in Grist that does not exist yet? Not a lot, because honestly, the Grist team has been extremely helpful, and they have almost magically created things that we didn't even know we need by the time we needed them. But there are perhaps some things that we are still considering about how to do. For instance, we might need something that would be let's say, an access role between an editor and an owner, someone that could edit parts of the scheme, but not all of it. Honestly, this might already be doable with advanced access rules, but the access rules do occasionally scare me when they get too advanced. Also, we are still considering it would be nice to have an ability to lock some of the columns for most changes, because it especially happens with formula columns that people will inadvertently change them and break things if you get them to right to do that. That's why a lot of our users are somewhat locked down, even though make life easier for them, they might require more access. So does anybody have any questions, comments, hate mail, anything? Oh, I see we have some questions in the comments. I just opened them. Let's see what we can figure out. Uh, all right, I see Eric has a question about the request function. Honestly, I didn't do a whole lot of work with the built-in request function, but I think it was basically a proxy issue because our internal self-hosting system is limited to IPv6. We needed to access some IPv4 sites on the outside. We had to use our internal proxy, and I was not able to get the request function to use the proxy settings correctly. It's probably doable. It was just one of those things that, it's 8 in the evening. Let's just get this thing done one way or another. I can look into that if you want at some point. Send me an email or, a Discord message, and I'll look into it again. But yeah, I think it was just a proxy thing because it is a bit of a weird setup. As for future requests from other users, basically they usually want to have more access to the system, but when we give them more access to the system, they start breaking things. So one thing that we are planning to doing is just, giving them their own little document to do their stuff in. But uh, the issue there is that there is some data that we would like to have shared between documents. Most of that is usually just the user data, and to a lesser extent, some of the tables. Uh, I see somebody's asking about uh, open sourcing our code. We have basically no widgets at this point. It's all small Python scripts. They haven't been open sourced yet because I didn't think they are actually worthy to be open sourced because they do deal with quite specific things like how to get data from an early 2000s data format and stuff like that. But I see no reason why they shouldn't be open sourced. I'll look into hosting them somewhere. I don't think we actually have an official GitHub account for a department, but we'll figure it out somehow. I have my own GitHub, we might publish it there. I see we have one more question. Is there a method of assigning tasks to your lab members? No, there is no such method yet. Our lab members are extremely independent people. Assigning them anything is a recipe for disaster almost. The only thing we are assigning people are, do your monthly reports, and yes, we are assigning equipment maintenance, which is done basically to, when you do the maintenance, assign the date and the person to do it again next year, and they will be emailed a week before it's time to do that stuff. But no, we are not actually doing any sort of task-related management, just because most people work almost independently or in a team of 1 to 4 people. So no, task management is not quite as relevant. Oh, all right. So how do the users like the system? Uh, it depends somewhat on the users, I have to say. The younger colleagues have taken it to it wonderfully. Some of the more experienced colleagues who are nearing retirement are a bit less keen on it, but they are all using it. I had no direct refusals to use it. As I said, some parts are a bit more user friendly and are getting more use. Things like monthly reports work basically beautifully. Keeping track of samples is a bit hard because you have to basically input all of your data while you're in the lab, and people already had a hard time inputting all the data into a lab book. So it is a bit of a cultural shift, but it is getting adopted. Now that we are implementing systems to actually design your processes and design how you're going to create your samples, people are more keen to then actually keep track of the process as well. But it is a working process. You basically, I'm afraid that for a team of this size, you need half of a person employed just to keep everybody on track. Okay, thank you, Jet. I'll finish quietly. Goodbye, everybody. Have a wonderful afternoon, evening, or whatever it is.